Oh man, I need a coin. All right, so the first thing we're going to talk about is experimental probability.
I thought I had a coin.
And the difference between experimental probability and theoretical probability. In experimental probability, you actually perform an experiment, and then you base your probability answers off of the collection of data. Whereas with theoretical probability, you go with the possible number, or the total possible outcomes, and then the theoretical ability to get a certain outcome. I don't have a coin.
I don't know what to tell you. I kind of think I did have a coin, and I have
I always have a coin.
Wait, I have a
Luke
chapstick.
has
It looks
a
like
coin.
a coin. It's just like big. And this could be heads and this could be tails.
I have a phone. You can flip
This
it.
is
Luke has a coin.
I have.
Luke has-
Yes. All right, hook me up.
wow. Luke is just an actual god.
All right,
It's
so
actually it's still recording.
we are gonna do this. We are gonna flip a coin 10 times and record the results. Ready?
Okay.
Okay.
Wait, that's
I
not
think that's tails.
That's not
I think that's tails.
I don't think that's how I flip a coin.
You don't. You like put it. Yeah, you put it on your thumb and you like. Yeah. Oh
There
god.
goes.
Oh god.
Don't you like catch it?
No.
Yeah,
You.
then you like.
Would you like me to
I
catch
mean, you
it?
can.
According to book rules of coin flipping.
In lacrosse officiating, you're not supposed to catch it.
Oh, really?
That's why, because you always screw it up when you try.
Yeah, you let it go to the ground.
Tails.
Wow, we have 7 more of these.
Well, because if you catch it, you could be altering the result.
Wait, this is what we're gonna be like doing during our tests, like flipping coins
If the
and
ground
stuff,
catches
and
it,
everyone's
you
like
can-
rolling around the room.
That's right, but
All
if the ground
flip
catches
coins.
it could be altering the results. Or the
Nah.
results. Excellence.
Just gotta stop
I
eventually.
bet 9
A
tails.
lot of tails.
9 tails.
Maybe you're just bad at flipping coins.
You can bet that $1.
Stop judging me and my
No,
twin flipping.
I don't wanna bet that.
See, that one's heads.
No!
I did it once with 9 of the same thing.
Oh.
That was a bad flip. There it goes. She's wandering.
Tails. I think. Wait, is that what the tails looks like?
Yeah, that's what the tails looks like.
Come
Now
on,
you know
let's
why I
see.
was confused.
Wait. Oh yeah, you're right.
I've ever gotten 10 of the same.
No.
Not heads. Yes.
You're still wrong.
What
You're
is
only
on the
flipping
back
it
of
10
it?
times. There's already 2 heads, so there has to like at most
The
there's gonna be 8
Apostle
tails.
Islands.
Come on,
Never
dude.
even heard of that. I need to study my geography.
Well, it's a good thing you're a math teacher, though, right?
Oh, indeed. Oh goodness, that doesn't count. That wasn't a
Indeed.
flip. Oh, that was not a flip either. But he flipped on the ground. We're just gonna go with it.
It
All right.
worked.
Very cool,
So
Miss
we
Red.
flipped a coin 10 times. When you're talking about statistics, you probably want to collect the most possible data if you're trying to make some sort of conclusion off of it. So if you're doing a study on people, you probably don't want to do a study on 10 people. That's not a big enough sample size. 10 coin flips, I don't know, probably not a big enough sample size, but I can't stay here all day flipping coins. You saw how long that took. So the experimental probability of getting a heads is the number of heads, 3, over the total coin flips, or the number of trials, which would be 10. So 3/10 or 0.3, or 3%. That's not the same thing. No, that's not. 0.03 or 3%. So you'll see it as a fraction, you'll see it as a decimal, you'll see it as a percentage. It just sort of depends on how you want to get your message across. Often when you're talking about probability, people no, it is 30%.
No. Oh yeah.
Yeah, it was 0.3. I was right.
All of us are just.
Don't doubt yourselves, guys. Often when you're talking about probability, you go with percentage because people tend to understand percentages like verbally more than they understand decimals or fractions. But you also might see like 3 in 10 coin flips are heads.
That's disgusting.
Like people understand that too, but they don't understand like 3/10 of every coin flip will be heads. They don't understand that. But if you say like 3 in every 10, people tend to understand that.
You say 3 of the 10.
Or if I could say like 1 in 4 people in this room will win $1 million. Oh, isn't that great?
That's very great.
Then you're looking around, you're like counting, you're like, oh man, one of them's gonna be us.
It's gonna be me. All the time.
And then percentages, I think people just tend to gravitate towards when they talk about probability. If I'm like,
Which one do you
there's a
prefer?
30% chance that when I flip this coin, it's gonna be heads.
Shouldn't it be 50-50?
Well, so that's the difference between experimental probability and
Theoretical.
theoretical probability. So theoretical probability,
Oh
put
man, I
right
have comments
here.
all down.
Meow. So theoretical probability would be Well, how many options do we have? We have the options of heads or tails. Okay, that's 2 total options. And if we want the theoretical probability of getting a heads, that's just going to be one of the 2 options, right? So I only have 2 options. Heads is one of those options, and I put that over the total options. So number of outcomes of the event that we're like kind of talking about, and then over the total possible outcomes. So let's scroll down and look at more theoretical probabilities. Okay. Do you guys know what a die looks like?
Yeah.
Sure.
It's got 6 sides. Like this. Okay, and then it's got like 1, and it's got like 2, and it's got like 3, etc. Okay. What is the probability of getting a 5 on one roll of a standard die?
1 out of
So
6.
how many total options of numbers do we have on the die?
12.
6.
You
That
said
goes on the
12?
bottom.
What?
1 die.
Just don't reply to him.
Oh,
He's just
I know.
saying it.
Just 1 die.
It's a stamp.
And then how many 5s are there on the die?
1.
1. So that's 1/6.
Ew, why do they call it a die? Like, and it's like spelled like
Die.
like you're gonna die.
One die.
Like not even like die
Dice.
like when you like dye something a color, but like die.
2 dice. Okay, so what is the probability of getting the sum of 5 on a roll of 2 dice? So let's just look at this for a second.
Sum of 5.
The first die has options 1, 2, 3, 4, 5, 6. Second die has options 1, 2, 3, 4, 5, 6. How many different ways can we get a sum of 5?
4 and
2.
1, 3 and 2.
Very cool.
3 and 2, 2 and
Okay,
3.
so 4.
Did I miss any?
No.
No.
So that's 1, 2, 3, 4. So that would be the numerator.
Wouldn't
Wouldn't it just be 1/6 again?
Different ways that I can get 5 from a roll of 2 dice. Dice.
My notes look so much better when they're like
Now,
in the note.
how many possible outcomes do we have here? Like 12. And how'd you get 12?
There's 6 on each side of 2 dice. Die.
Okay, are you sure?
Not really anymore.
You have to remember our fundamental counting principle.
Yeah, I don't remember that.
Yeah,
So
it should be 12.
So in the fundamental counting principle, we did this.
yeah, I still don't know what that is.
Go look back in your notes.
I probably didn't write it down.
The number of ways m can occur followed by n. How many ways can the first die roll occur? M times n. I can't say times either.
Oh.
When you roll a dice, you have, when you roll a die, you have 6 possible ways that you can get an answer, and then you roll it again, you have another 6.
That's 36.
Oh, you're multiplying. That's disgusting. Gross.
This should simplify to
To
1/9. Okay, there's a U try. U try.
To my
So,
flip flat.
how many odd numbers are on a die?
3.
Trace of.
1, 3, and 5.
3, and 5. And how many numbers are there total on the die?
6.
So there's a 1
All of our
in 2 chance,
problems be like
50% chance.
Easy money.
Easy money. I thought I got it wrong. I questioned it. You're like, all of these are repeating, and I was like, oh my god.
I know, I could feel it. I'm like, I think it's Pat, Emma.
I got really scared. I was like, am I that dumb?
Perhaps this is the question that you saw on the homework. Does everyone know the cards in a deck?
No.
Yeah, it's 52 cards.
Let's
on one.
quickly just talk about cards.
I don't play cards like that.
I really like that.
I am very good with cards. I love cards.
I'm like actual trash.
I know that there's,
Why is
like-
every single square getting
I know there's like the heart and like
Because that's
the,
what I do.
the
my
clover.
the
Spade.
clover. The clover.
I mean, there's a.
The clover.
It's not called a clover
The
though.
clubs.
It
It's
is.
called a club, yeah.
Yeah. It was like,
She's not
And the
wrong,
diamonds.
but like,
It's
a
technically a clover.
but like no one calls it
Yeah.
that.
well, I
It's a
did.
club.
Well, who taught you that?
Tristan.
hard.
It
Tristan?
doesn't matter if it's what is.
I always
it
thought it like
called
who calls it a clover?
Me. It looks like a clover.
I understand this.
We're recording all of this. So you have 4 suits. Spelled like sweet, but pronounced suits.
Ew, that's disgusting.
Like a suit and tie. So you got 2 black suits, the club and the spade, and then you have 2 red suits, the heart and the diamond. And then you have face cards. You have the king, the queen, the jack.
And
They
the
have
the ace.
they have faces on them
I
because
was
it's
just gonna say the
it's like a
princess.
king, it's a
Holy
queen,
crap.
and the jack.
Oh, interesting.
Ace is not usually a face card.
No, but it's
Wait,
important.
no, there are
It is, yeah.
cards.
Like the
No.
ace of spades is the most
Joker.
important.
Is
After-
it ace 1, 2, 3, 4, or
There's
8,
54
9,
cards.
ace?
After the jack, you go from 10, 9, 8,
That's what I was
7,
thinking
6,
about. Alright.
5,
I'm not-
4, 3, 2, and then there's no 1. That's where you have ace. So in blackjack, ace can either be an 11 or it can be a 1. You get to like pick.
Wouldn't you want it to be higher? I don't know how blackjack works.
It
so
just
like,
depends. Yeah, we're not
Can I
gonna
use the
talk.
restroom while you do this?
Yeah, we're not gonna talk too much about
So you're
that.
gonna come back
So-
with something.
How many things did I just list here?
1, 2, 3, 4, 5,
5,
6,
6,
7,
7,
8,
8, 9,
9,
10, 11,
That was in my
12,
bank
13.
account.
So there's 13 total cards for each suit, and there's 4 suits. So how many total cards do we have?
4 times 13. I can't.
Yeah, 52.
Okay,
So
thank
there's
you.
52 cards in the deck. We never really talk about the jokers, okay? We always pull the jokers out when we talk about this because jokers aren't used in like real card
So we're not
games.
counting them then?
So we're
These
not
are
counting
fake card
jokers.
games.
But
In
that's still
summer camp
52.
games, they're
Yeah, so with jokers, there's 2 in a deck. That would be 54. So that's why it usually says from a standard 52 card deck, so that you can just take those jokers out.
So the
Sounds funny.
Oh.
All right, so we want to know what the probability of dealing 2 sevens in a 5-card hand. So we got 2 sevens, and then the other 3 cards are we don't care.
we don't care.
We don't care what they are. There's something else. Yeah.
So we only want 2 sevens, we don't want more.
Well, that's what we're looking for, the probability. And I don't know what we want. Maybe we want 2 aces, but we're trying to figure out what's the probability of us getting dealt
So
2
is there a
sevens.
7
Like,
for
I would
each
do
of the sweet suits?
Yeah.
The suits.
Yeah.
Suits.
There's a king
Yes.
for each
Suits.
for
I'm
each
so sorry.
suit, and there's a 7 for each suit. Now this is like I took a deck of cards and I was like 1, 2, 3, 4, 5. What's the probability of 2 of those being a 7?
Not much.
What? You probably think not much because there's an awful lot of cards
Is it
and
like 4
only
out of
4 of
52?
them are 7s. No, yeah, you wish it was that one.
I wish it was that easy.
So first we're gonna look at the number of combinations of 2 sevens from 4 sevens. So notice this word combination. So we're looking for combinations of 4 sevens chosen 2 at a time. So like a set of 2 sevens from our total number of sevens.
I don't get what it's saying to me right now. The number of 2 sevens.
So of our deck, how many sevens we got?
4.
We wanna know,
28.
we wanna pair them up
Oh
in a
my
set of
God,
2.
you said 28.
because we're looking for the probability of getting 2 of them. The next thing we're gonna look at, so that would be like, it's kind of like representing this piece right here. Then what about the other cards? So 3 non-sevens. So how many cards are non-sevens?
3. Oh my god, you mean like overall?
Wait,
52
what?
minus 5, 48.
There you go. So it says it actually there.
Leave me alone.
Sorry.
Wow.
There's 48 non-sevens
Wait,
and
where
we
does
want
it say that?
we want 3 of them after that. That's this part.
Rip?
So 2 of them are 7s, 3 of them are
There goes my
non-sevens.
math grade.
The total number of 7s, how many we want to know the probability of, the total number of non-sevens, and then how many would be
I
left
really
in the
like
5 card
subtracting,
hand.
and it's right there.
So once again, you got total number of 7s, we want a set of 2. Total number of non-sevens, we want a set of 3. Does that make sense?
I suppose, sort of.
So this part is representing this situation here. And then this part is representing this situation here. And we have to do this because they're all being dealt at the same
Should I
time,
draw
like in
that out? Because I
sets.
did not do that.
Up to
Should
you.
I?
So this could change. Let's say it was just the probability of dealing 1 7. So how would this change? The only things that would change is this would be a 1, and then this would be a what?
But how do we know?
So if this was a 1, this would be a 4, because we would want a 5 card hand. And if the 5 card hand part changed, those numbers would adapt. So you want the total number of what we're trying to find the probability of. We want that first here, and then how many of them we want. And then the second part, you want the total number of whatever we're not trying to find the probability of, and then how many of them we want. Now if we multiply that together, which we're gonna do on the calculator, we will get the numerator of our probability. The numerator of our probability is like the possible
I
outcomes.
think this is what the problem is like that we all have to do. Because
So
when you
this
put it over
is
something too.
the numerator of our probability. The ways that we can get 2 sevens.
Yeah. Do we need to write down the part under it too? The
And then
Yeah.
get it
5 card
outside.
hands?
That's the denominator.
Done.
So the total possible number of outcomes, so total outcomes, that's what goes in the denominator. That's the total number of possible 5 card hands. So how many cards do we have?
52.
And we want them 5 at a time, because 1, 2, 3, 4, 5.
This is so disgusting.
That's our denominator, the total number of 5 card hands.
Like this makes me uncomfortable.
Well, would you
Like,
rather
this
pick
is
up that
too
fly and
much.
throw it in the trash or do
Now
this
I
math?
need a calculator. There is a way to do this without a calculator, but it would take a really long time. So we're gonna use our calculator and practice. Do you guys remember where to find those things
Yeah.
on the calculator?
I'm
The
kind of lucky
exclamation
because
points are
mine
like
just
the bottom.
says it.
I can't see.
My calculator is awesome.
My calculator.
I spent $20 on this bad boy.
I wonder if this will work.
It's everything I need.
Have you
So you're
seen
gonna go to
that?
menu.
I
Actually,
can't
before
see.
you go to menu, you're gonna go to
Statistics.
the fraction button, and
Fraction
then
button.
menu, probability, combinations, and then we're gonna do 4, choose 2,
Okay, you're gonna have to.
Do you
start
click that?
with
You hit the number.
times.
Do you hit the number before the
Tristan.
NPR and NCR?
No.
You hit the NCR
You type,
before.
yeah, and then you put in commas.
For sure.
Like 85%.
So you do menu, probability,
Oh my god.
combination,
Wow. Menu.
and then like number, comma, number. So I'm on like 52, comma, 5.
Wait, you do that 52, comma.
You put parentheses
Where's the
around it? Is that what
comma?
you did?
Comma is bottom left.
Did you put parentheses around it?
No,
They're-
I
they
made it,
come
I
with
made it a
parentheses.
fraction. I used the fraction bar.
Oh my god. Wait.
What did
Can
I
you
do
can you
wrong?
come here and help me, please?
Yes.
I'm a little
Let me
lost
just
in
get
what
it up
that
here
was.
so that other people can check
Leave
theirs.
it outside.
I'm gonna round
I'm not even
to.
asking you. Just not.
I didn't plan ahead, so I'm rounding to that many decimal places. I have to round this to the thousandth place. That would round this up to 40 instead of like 39. So it's about 4%. So like you predicted before, pretty low.
Pretty
Okay.
low.
So was everyone able to get this on your calculator, this part?
Yeah, if I knew how to do that, I was
Now,
literally doing it like manually.
Remember, if you don't have a calculator, what did we have to do? You remember?
I like
Oh,
did
you
them all
crossed-
separately.
Yeah.
It involves factorials.
Yeah, that would have been a
So
crap ton
like
of
this
work.
factorial
Ew.
over 2 factorial times 4 minus 2 factorial. And then you would have done, ooh, this is a doozy, 48 factorial over 3 factorial times 48 minus 3 factorial. Woo! And then this would be 52 factorial over
You'll never
5
make me do this,
factorial,
right? Because I will
52
drop
minus
out.
5. No, I'm just saying, this will be on your quiz, but with smaller numbers. So
Oh.
the combination
We
part,
won't have our calculator?
nah.
What?
You're not gonna do this
You heard
question
her.
on my
She
quiz.
said nah.
Now listen,
When is the quiz tomorrow?
Oh
on
my god,
Wednesday.
no. Oh my god, wait. What is today?
It's Wednesday.
this is
No,
Wednesday.
this is Wednesday.
Yeah.
Oh,
Yeah.
I thought today was Wednesday.
Don't
This
be a- don't be a
question can
goofball.
be rewritten without cards. It could be rewritten for other things that you're trying to find the probability of making sets
How
of
did
them.
you try?
Keep that there because
So
it's essential.
when you're doing sets of things, you're gonna need the combination or possibly the permutation.
Sorry.
For this particular question, we're not looking for any particular order. We just wanted to know like 2 sevens out on the river. I don't know what they call this, lingo.
Mango?
If maybe we're not dealing 5 cards, maybe we're dealing like a 3-card hand.
How'd the get-go?
All the rest of the wording is the same. We'd get rid of this. This would change to 1, because there would only be 1 non-7. Okay, everything else would be
When we do
the
the you try,
same.
can you leave
This
that
would
all
be a
open?
3.
Ah.
Okay, that's how it would change if it was a 3-card hand instead of a 5-card hand. Okay. What if the verbiage changed to 2 face cards?
Face.
Now there's a lot of face cards. How many face cards? There's 3 for each.
But we're not counting the jacks.
12. I'll take a
No,
pick
you
under.
count the jacks.
Well,
Jacks have faces. So there's 12. So you change this
Would you take it?
face,
You got it.
face.
Just take it.
You change this to 12. Okay, this would change to 12.
Nauseous.
This number would change to 52 minus 12, which is
On the game.
40. Okay, and that's how it would adjust.
You always gotta adjust.
Okay, so you see how it can be adjusted with different verbiage.
Oh my god, this is gonna be so bad. Me doing this, you try.
They also don't necessarily have to be cards. That's just like the most common.
Do they not always like list out like the stuff?
That's not listed out. That was like for note taking,
Oh my
like, so
God.
that you could have like good notes.
I'm gonna
for
have
this.
to like know like what.
But that's why it's there, so you can kind of
Okay,
adjust it
2
for. So
sevens.
let's look at the U try. Try to adjust like that logic.
Of course, like when my U tries, I went to the next page.
Yeah, I know.
I say that correctly, Miss Red?
Yeah. sort of.
Yeah.
So the first combination that you want. So you're looking for how many
Yeah,
total
whatever, 5,000.
sevens we have in the deck. So we have a total of 4 sevens. We want them dealt in a set of 4. That's the next 4. The first number in a combination should always be greater than the second number, so just keep that in mind. Or I shouldn't say greater than or equal to, but if it was like 2 and 4, that wouldn't work. It'll say meow.
We'll say meow.
Now this part right here, we don't care what that 5th card is. One of the cards we don't necessarily need it to be a 7, it's something else. So there are 48 other cards that aren't 7, and we want one of them in this probability.
I moved it so it would be inside notation.
The reason we multiply is because of the fundamental counting principle. This is the number of times m can occur and the number of times n can occur. We multiply m times n. Then we're going to divide that by the total possible outcomes. Total possible outcomes is our 52 total cards dealt 5 at a time. And I guess when you plug this in your calculator,
1.847 and then like e -5. So do you move it over left, over the like to the left 5 times? So it's just like 0.0000185. Because it's just like it's like large and in charge.
so
Large and in charge.
1.847
7.
and then other digits, e -5. So you're going to take this, you're going to move it over 5. So that's 1, and then 2, 3, 4, 5. You're going to put zeros in there. So 1, 2, 3, 4 zeros, and then 1, 8, 4, 7. That would be the decimal. But it also just gave it to you as a fraction. 1 in 54,145 card deals will be like that. That's kind of like how they would word a probability to make it sound favorable. Because even though that's a really big amount, it makes it sound like it could happen.
Not specifically. I wouldn't say that.
When I word it like that, doesn't it make it sound possible?
No.
Really?
That's
I
a
think it
large
does.
number.
It's like 1 in 54,145 card deals will be like this, 7 4s.
But like that is such a large number.
Yeah, but it makes it sound like it could happen.
If you said 1 in 54, it would be like, oh okay.
Yeah.
But like 1 in 54,000.
1 in 54 is still like kind of unlikely if you ask me.
I know, but that's more
I'm not a
probable than
gambling man.
54,000.
I know. Well, good. So you won't be scammed by the statistics.
I don't think anyone will be.
I don't think
Tell
you have to
them-
like
I'm just saying when they
prediction.
word it that way, when they say like blank and blank, it makes it sound like it's guaranteed,
Okay.
and it's not guaranteed.
I suppose if I listen to
Yeah,
it,
you always-
Theoretically probable.
Like you
if
don't
I just
have
like
to say
listen
with
to it really
confidence.
fast.
Yeah, yeah.
We'll be unlucky.
That's
a
what
lot.
they do with statistics. If you say anything with confidence, you manipulate the statistics in a certain way, and you get people to believe things. And that's why I don't like
It's like giving
statistics.
it's like giving presentations. The more confident you are, the more likely people are to believe you.
Like no one's gonna
Yeah.
question you. You can literally say like the stupidest stuff. And you sound like you know what you're talking about. People are gonna be like, yes.
Me
Yeah.
and AP
I
psychology.
agree.
Me and AP psychology.
Just shout.
You.
All right, so
I just like say random
this
stuff.
picture is representing a
Yeah,
strike zone,
This board
like
is
a
like
batting
this.
strike zone. So the yellow box is representing the entire strike
Oh my God,
zone
it's the batting.
in inches.
The batting little box.
And then so we're trying to find the probability of the pitcher throwing in the high inside right area of the strike zone,
Brayden, you should get this answer.
Yeah.
right.
which is
Oh,
like
me?
this
I've
little
never
area. So we're gonna use
I know what a strike
geometry
is.
to find probability,
Oh my God.
which if you took geometry here last year, you should have probably done this.
We did.
We
I
did.
wouldn't.
Probability with area.
Oh.
So what we're gonna do is we're gonna find the area of the, whatever color you wanna call that,
24.
orange, and divide
Inches
by
squared.
the yellow. So area of orange
24.
over
Should I draw? I'm gonna draw
area
this box.
of
Give me a minute.
yellow.
Uh,
And that'll find the probability, if he's thrown in the strike zone, of him getting this area of the strike zone. So yeah, it's gonna be 24, because that's the
374.
area of the orange little rectangle.
Like,
For
rectangle
him, 6.
squared.
374.
You multiplied 22 and 17,
Yeah.
374.
Did
And
you do that in your
then-
head?
What?
Did you do that in your head?
Yeah. That's weird.
Nah. So as a fraction, this will simplify to 12 over 187. And as a decimal, it's about 0.06.
Guys, I'm gonna fail this chem quiz. It's
You
really
ready?
good. No.
I have so much faith in you right now
Control,
that you're gonna
there's
do
a
great.
spell.
Thank you so
No
much.
problem.
Kind of picture.
I tend to do better when I think I'm gonna fail, so.
I
Set low
mean,
expectations
they're
and
supposed
then
to be
what
able
you
to.
What'd she call
Yeah.
it again? It was